Alright, welcome to Geometry 3-5.1. We're in proportions in triangles. And we have a few theorems to look at today. The first one is the side splitter theorem. And what this says, and I'll read it slowly so you can fill it in, is that if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides those sides proportionally. So I'll say it one more time. If a line, in this case RS, if a line is parallel to one side of a triangle and that line intersects the other two sides, then it's going to divide the sides proportionally. And again, what does proportion mean? It means the ratio of this divided by this will be the same as the ratio of this divided by this. And that's the side splitter theorem. Let's take a look at a corollary to this. Alright, this is the corollary to the side splitter theorem. And again, I'll start slow. I'll change the color to this to something different here. Orange. Okay. What this says, it says if there are three parallel lines that intersect two transversals. So if there are three parallel lines that intersect two transversals, then the segments intercepted on the transversals are proportional. So one more time. If there's three parallel lines that intersect two transversals, then the segments intercepted on the transversals will be proportional. Again, the distance from A to B over the distance from B to C will be proportional, the same ratio as from W to X as X is to Y. That's the corollary. So you have three parallel lines that are intercepted by two transversals, their segments will be proportional. Okay, let's look at the last one, which is the triangle angle bisector theorem. And I'll read this slow too. This is a simple one. It just says, if a ray bisects an angle, so you can see that these two angles here, so this ray that's coming from the ray that's bisecting angle CAB here, it's coming through and it's splitting so that each of the new angles created it's bisecting are the same to each other. So if a ray bisects an angle of a triangle, then it divides the opposite side, this side right here, into two segments that are proportional, so the distance between these will be proportional to the other two sides of the triangle. So this ray, when it goes and bisects an angle here, the two segments, I'll just read it from the top so you have it. If a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So again, the distance of C to D divided by D to B, that this will be proportional to CA is to BA. Now, obviously, you're going to use these proportions now from all these corollaries and theorems in order to find missing sides and to solve and use a little bit of algebra in there. So good luck, and I'll talk to you again soon. Thanks.